In this video, I want to revisit this notion of pass-by-pseudoreference. Okay, so let's say we have a method called static int foo that receives a string s, and then let's say it mutates the second element to be the string haya. Okay, and then it just returns 0. So we don't really care about the return value, but we're just gonna say it returns a value. Okay. We could make it void. Again, void means it doesn't return anything, but we'll just, there's a reason why I don't really like to make void methods, and that's because you can't test them easily. But we're not going to be doing testing in this video. We're going to be doing that in the next video, but regardless. Okay, so let's first create an array, and we'll just say string s again equals new string. And there's actually something I want to show off. There's this technique called an initializer array. It's actually called an initializer list, but I think that's a terrible name because this isn't a list, this is an array. So let's say we want to pre-populate an array with values. Well, we can do that by just passing braces on the outside and then giving it the elements that we want to store. So for example, let's say we store the string Joe, the string Bob, the string Carol, the string Dave. Let's do Alice. So there we go. So yeah, so now S is an array of 4 values. Now notice that you can't pass the size if we're using the initializer array. And that's just because, well, it'd be redundant to say that it has 4 values and then you pass 3. But even worse, what if you pass 3 and then you actually give it 4, right? So either give it a size and don't give it predefined values, or give it predefined values but don't give it a size. Okay? So let's also see, so there's some other methods that we can use in the what's called the arrays class. Okay, so let's say that we want to print out a stringified representation of an array. Now, this is actually very easy to do, but let's say that we just want to just very quickly see what this array looks like after printing it to the console. So we can just use system.out.println, and then we're going to do arrays dot and then toString, and then pass it s. Now it's going to give us an error because we need to do import java util arrays. Okay. What's wrong? Oh, okay. So I probably should not have called this class arrays. Let's call it array examples. So now we can do arrays. Yeah, there we go. So that's okay. So don't name your classes after actual Java classes. Okay, and especially if you're going to use methods from the other class. Now there is a way to circumvent that. I should let you know, but in general, naming this class arrays was a bad idea. Okay, so let's see what this looks like just very quickly. Then it prints it out like this with the elements separated by commas and a space. Very good. So now let's see what happens if we just do, so let's print out foo, and then we're going to pass it s. Okay? So let's see what happens. So this should obviously return 0, but there's a side effect with this method. Okay? We changed the second element, or sorry, the third element, which is at index 2, we changed it to haya. So if we print out the array now, we're going to see that it says haya. And that's, methods shouldn't have side effects like this. So, I mean, like, what's the solution? There's no real solution to this. It's just something you shouldn't do. But the point here is that when we pass the array, we're going to pass it by pseudoreference. Okay, we're going to get the reference of the array, the memory address. We're going to pass that to here, and then we're going to mutate it inside of here. So when we mutate s, we're mutating the array at the given address. Okay? Now, again, that may make you think, well, then Java must be passed by reference then for certain things, but it's not. It's passed by value because we're passing the address as a value. We're creating a copy of the address and passing that to here. Okay? But what exactly does that mean? Well, if we change what s points to, so let's say we do s is equal to new string of, let's say, 100. What that's going to do is, so Java's even saying here, hey, this should be a local variable, but so you may think, well, if this is passed by pseudo-reference, then, and we change what s is pointing to, then that must mean that this gets changed as well. But that's not true. So if we run it, we'll see that it still prints out the same array. And the reason why is because we pass a copy of the address. Okay? So by passing a copy of the address, the original reference stays the same. And it's just that this change happens locally. Okay? So the copy of the address that we pass changes or gets changed to point to this new array of strings. Okay? Now, we could return this new array, that would be fine, but the point of this is to show that Java is not passed by reference, it's passed by, again, pseudo-reference, but in actuality it's passed by value, but understanding why it's passed by value is, I think, a little tricky for a lot of beginning Java programmers, and it's very easy to screw this up. So I think that this example and the examples that we just showed demonstrate what it means to be passed by pseudo-reference, and more generally to know that Java is passed by value.